Hey guys, what's up? Welcome you to my next video, and this video is going to be the next video from haloalkanes and haloarenes, and I'm like very close to completing the chapter, and I'll be really relieved once the chapter is over because this is the first chapter of organic chemistry. I've been trying to make it happen. So right now the topic I'm going to take is going to be a small one, and tomorrow I'll possibly I will complete almost all the topic from the haloalkanes. So right now the topic I'm interested to make you go through is called Grignard reagent. So that is what the topic is. So let me write this topic. Grignard reagent. So what Grignard reagent is, as the name suggests, there is something it has to do with the name, right? Just give me a second. So it has something to do with the name. I'll tell you what, there are some of the metal which can react with the haloalkane. You need to understand that some of the metal can react with the haloalkanes, and when they react with the haloalkanes, they form an organometallic compound, and that particular organometallic compound is here called Grignard reagent. One such compound was discovered by a scientist called Victor Grignard. So that is what the thing is. But let me write because you may not pick up everything I say. So some of the alkyl halides some of the alkyl halides can react with some of the metals. Some of the metals like magnesium, and they form organometallic compound. Organometallic compounds called Grignard reagent. Organometallic compounds. One of such compound was discovered by Victor, or I should write name only the half part, by Grignard. His full name is Victor Grignard. So what I'm trying to say that some of the metals can react with the alkyl halide and they can form a specific compound, and that compound is called organic metallic compound. What is the specific of this particular compound? Let me take you through the example here. Suppose alkyl halide like RX, when react with magnesium, what they do, they form alkyl magnesium halide. They form alkyl magnesium halide here, and this is what called Grignard. This is what called Grignard reagent. Now, this compound has something specific. You have to concentrate that this compound has something specific. The bond between alkyl and magnesium. The bond between alkyl and magnesium is covalent. The bond between alkyl and magnesium is covalent, but the bond between magnesium and halogen is ionic compound. So what you see out here, that there is something interesting about the compound, that this compound has a part of covalent compound and has some part of ionic compound. Where is the covalent part? The bond between R and Mg represent to a covalent part, while Mg and X represent to ionic compound. So this is how Grignard reagent becomes a very, very important thing. Let me take you, through some example here. So I hope you have, in case you need, you can copy that. Let me write that example over here. Suppose I'm talking about this particular, chloride. So this is your chloroethane. Now when chloroethane react with magnesium, it forms, this compound. What this will be called? This will be called ethyl magnesium chloride. So this is called ethyl magnesium chloride. This is also called, Grignard reagent. Why? Because Grignard was the first person to, make a compound something like this. Now I repeat back here that Victor Grignard, made this, compound. So this is also called Grignard reagent. So what you can also call it? You can also call it Grignard reagent here. So this is your Grignard reagent. Now what next I am interested to take you through properties of Grignard reagent. Grignard reagent. The first thing I would say, it is highly reactive. It is highly reactive with a source of proton. With a source of proton like water, maybe an acid or other. So what that means, Grignard reagent is very much reactive, and this must be prevented from coming in contact with the source of proton. What will happen if the Grignard reagent, like anyone, so I'm taking an example, RMgX here, RMgX, this is a Grignard reagent. When it comes in contact with proton like water, it immediately reacts and it immediately reacts and form alkane. So this is your Grignard reagent. This is your Grignard reagent, and this is your source of proton, and it reacts to form alkane. So what will happen basically? It converts, haloalkane, it converts Grignard reagent into alkane, right? And apart from that, another product which is also formed is MgOHX. So this is another product you see out here, MgOHX. So this is called magnesium hydroxide halide. Now, what important part is there, how the reaction takes place here. See, a magnesium and halogen has a positive charge, while the alkyl group is having a negative charge. Similarly, in water, there are two ions. So one is H positive and other is OH negative. So how the reaction takes place, that is very important. I'm going to tell you. See, R comes out with the positive, so it reacts RH, and MgX come out with OH, so it forms MgOHX. So what the conclusion is coming out to be, if Grignard reagent is prepared, it must be prevented from coming in contact with the source of proton, because if you do not do so, what will happen? It will convert back into the respective alkane. So this is what very important, Grignard reagent, I can talk to you about. So this is one of the property of the haloalkane. I tried to make you go through. In case you have understand, let me repeat back the whole thing. The first thing I said was, when an alkyl halide, react with magnesium or some metal, it forms, organometallic compound. One of such compound was discovered by Victor Grignard. So this is also commonly called Grignard reagent. Now Grignard reagent is highly reactive, especially with the proton, especially with the H plus. So it has to be prevented from coming in contact with the source of proton like water, alcohol or anything. So if it comes in contact with water, what happens? This is what happens, in the reaction. The magnesium halide part react with the hydroxide ion and the alkyl part react with the proton. So alkyl part react with the proton and it form alkane, while the other two remain and converts into magnesium hydroxide halide. So this is the reactivity of Grignard reagent with source of proton. I hope you have understand. I've tried to make you this, very short topic in a very simple way and very helpful way, right? So that's it. With that, I must say, this is, the one very important thing about this reaction. In case this is coming out to be a conversion, you need to understand this may be used as a conversion also. But right now I'm taking is, suppose this is the kind of, this is a haloalkane I have taken here. Now what happened? You have to react it with magnesium. I've taken this on a random basis. So what happened here? You have to understand that the magnesium will react with the, this particular carbon to which the chlorine is bonded. So what's going to happen here? This is what's going to happen. C, there is another C out here. Then there is next C, and this C will react with the, this C will react with MgCl. So this is a Grignard reagent. What I did, let me just, write the name. Grignard reagent. What did I just do? I just, reacted the magnesium with the carbon to which the halogen is bonded. This magnesium go with the, carbon to which halogen is bonded, right? So that's why this product has converted. Now what will happen? What will happen here? If it is coming in contact with water or any source of proton. So I've told you already that water contains two ions, H plus and OH minus. So what will happen? This will react with, this is your positive part and this is entirely your negative part. So this will react with OH and it will form, MgOH Cl, and this will convert into a alkane. So the product, another major product is going to be C. There are two more C up and down here. And then there is another C out here, and there you have C, and this will react with the hydrogen. This will react with the hydrogen. So this is how, this is how the reaction take place. So let's place some hydrogen so that you don't have confusion right here. So this is a kind of alkane is formed. There's nothing used here, but you have to understand how this reaction is. So they will give you any kind of reaction in order to convert from haloalkane to an alkane. So another reaction I'm about to take you through is that there is something very important I still have to tell you, and that is I hope you have started thinking about. So what I'm missing here is like you have understood almost everything. One very important thing: what if the what if you wish to keep the Grignard reagent not coming in contact with the water? Listen to me. This is very, very important line. What if there is there is a need that the Grignard reagent should not be coming in contact with the water? So in order to prepare, let me repeat, in order to prepare Grignard reagent and in order to stop further reaction of Grignard reagent with water or any proton source, this reaction has to be stopped right here. So this reaction has to be stopped right here. So how this can be stopped here? You have to use here dry ether. You need to understand what you need to use here, dry ether. Because if you use this dry ether, you have to understand very, very important this is going to be. So if you do not use the dry ether, this will react with the source of proton and further reaction will take place. But if you use dry ether during the preparation of Grignard reagent, this will be prevented from coming in contact with the water. So let me write this the whole thing. Since Grignard reagent is highly reactive towards source of proton. Therefore this reaction is carried out in presence of dry ether, which prevent it from reacting with water, or with proton, and stop the conversion into alkane. So let me repeat back this whole thing here. In order to prepare the Grignard reagent and stop it from further reacting it, this reaction is carried out in presence of dry ether. Why dry ether has to be used? Dry ether is a simple source that utilize the proton, and simply you can say it absorbs the moisture from the air. So dry ether is used in order to remove the moisture, so that the Grignard reagent doesn't come in contact with the water. So this dry ether, what is the role of the dry ether? This is what I have explained here. What I have explained here is that Grignard reagent is very, very reactive, and if it's very, very reactive, it's react with the proton, and this result formation of the alkane. But if you use the dry ether will not let the reaction. So with that, I must wind this short video. I would say thanks for watching.